what we are starting with today is a lot of vocabulary. I don't think today's a tough lesson, but there is a lot of vocabulary involved. I think that's probably the hardest part about what we're looking at today. So just follow along with the vocabulary and take decent notes and make sure you are preparing yourself well for the rest of this unit, because we're going to use a lot of this vocabulary as we progress through Mod 6 here. But like I said, today I don't think it's an overly hard lesson. It's just a lot of new vocabulary that we're going to be using when we're talking about it. First thing we're talking about is the initial side. Whenever we have an angle drawn, there's always going to be an initial side. And it doesn't matter where the angle is drawn. I could draw an axis like this, and we could draw a side length like that and another side length like that, and say, okay, this is our angle, and our initial side is this yellow one here. Okay, so the initial side could be anywhere. We're going to look at a lot of examples where it's on the positive x-axis though. And what the initial side is it's the starting point of an angle of rotation. So I notice I drew an arrow here, but the arrow starts at the yellow line and then it goes to the green line. That's the idea here with this initial side versus a terminal side. That's how you can tell the starting point versus the ending point. The terminal side is the ending point. Of the angle of rotation. Now, a majority of the angles we're going to deal with in this class are specifically going to be angles that are in standard position. And what that means is it has a vertex at the origin, 0, 0, and its initial side lies on the positive x-axis, which is exactly what we see over here on this graph. Positive x-axis, that's the initial side. Okay. So our first example today, we're going to draw 3 angles here in standard position. But before we draw them, we want to talk about 2 types of rotations. There's a clockwise rotation and a counterclockwise rotation. So what we can see up here is this angle rotating in a counterclockwise rotation. All right. And basically think about the quadrants of a graph. This goes way back. Some old school math knowledge we've got. And notice the degrees here. It starts with 0 degrees, and then it rotates to 90 degrees, then 180 degrees, 270 degrees, 360 degrees. I said this unit's about circles, and that makes sense. A full rotation in a circle is 360 degrees. And notice we rotate through quadrants 1, 2, 3, and 4. We're going through them numerically in a positive direction. And that happens to be a counterclockwise rotation. That's why a counterclockwise rotation would be considered a positive rotation. And it just means if I start on the initial side in standard position and I'm rotating somewhere, anywhere, counterclockwise, that's a positive rotation. A clockwise rotation then would be considered a negative rotation. And that's just the opposite. It's going to rotate in a clockwise direction. And we could end up in the exact same spot, but maybe one time we rotate clockwise negative direction, and the other time we rotate counterclockwise positive direction. And we'll end up in the exact same position, but one of them's a positive rotation going through the quadrants 1, 2, 3, 4, numerical order. That's positive. That's counterclockwise. Or we go clockwise, 4, 3, 2, 1. We're going negative direction through the quadrants. That's the way I remember positive and negative myself. All right. Now I'm going to sketch 3 angles here. I can tell whether it's a positive or negative simply by looking at the signs out front. So examples A and B are positive rotations. Example C is a negative rotation. First thing I'm going to do, I'm just going to go ahead and draw my initial side for all 3 of these. Here's my initial side. And I'm going to rotate 290 degrees in a positive direction. Well, I know I get a 90-degree rotation by the end of quadrant 1. By the end of quadrant 2, I'm at 180 degrees. By the end of quadrant 3, I'm at 270 degrees. And then I'm going to get slightly past that because it's 360 degrees is a full circle. And I'm not quite going all that direction. So this shows a positive rotation of 290 degrees. That's what the red arrow is representing. And the green line's representing the terminal side. The yellow line's representing the initial side. That's how this one would work. On example B, 420 degrees, I'm going to complete a full 360 degree circle, but then I still have to keep going. So real quick here, I'm just going to say, let's subtract 360 degrees. And I'm going to get another 60 degrees. So I have to go 60 degrees past a full circle, which is going to end me somewhere in quadrant 1. And that's how I would draw my rotation here and say this is a 420 degree circle. So if I go more than 360 degrees, I'm just going to draw the circle more than once through there to represent 420 degrees. And then the last one says negative 240 degrees, so I'm going to go in a negative direction instead. So instead of counting positive 90, positive 180, positive 270, I'm going to go in a negative direction, negative 90 degrees, negative 180 degrees, negative 270 degrees, negative 90, negative 180, negative 240 is going to end up somewhere over here. And I just want to make sure that I'm in quadrant 2. And that represents a negative 240 degree rotation. That's an example of a negative rotation, 240 degrees. That's how I would draw that one. Okay, that's what these angles in standard position look like. Okay, so we draw our initial side, our terminal side, and then we draw either a counterclockwise positive rotation or a clockwise negative rotation. Okay. Another vocabulary word we might use is called coterminal angles. And it says in example 1b, we had a 60 degree and a 420 degree angle. And the 60 degree angle came from when I said, oh, let's subtract 360 and see how much further we have to go. So technically what that means is if I started and I just drew a 60 degree angle, I'm not going to rotate 420 degrees. I'm just going to draw a 60 degree angle. Technically, I would be drawing the exact same angle. It's got the same starting side and the same ending place. The only difference is I rotated 60 degrees instead of 420 degrees. That's called a coterminal angle. So coterminal angles are going to have the same initial side and the same terminal side. And since they're both in standard position with coincident terminal sides, all right, which means they end at the same place, that's called coterminal, which makes sense. Co, together, terminal, finish. All right, so that's the finishing at the same spot. Okay, that's what coterminal angles are. The way we can find coterminal angles mathematically is actually pretty straightforward. In example 2, we're gonna find one positive and one negative coterminal angle. But first, I want to go ahead and draw these angles. So first one, I'm going to draw a negative 45 degree angle. Negative 45 is just going to be halfway through this direction. Whoops. And there's my negative 45 degree angle. The second one's going to be positive 395, which means I'm going to go full 360 degrees in the right direction, the positive direction, and then another 35 degrees to get to my terminal side. So somewhere in quadrant 1, that's a 395 degree angle. So to find a coterminal angle, what I could do to find a positive coterminal angle, you typically would say, let's add 360 degrees. We want to find basically an angle that's going in a positive direction that ends at the exact same spot. That's the goal. I want to find a positive coterminal angle. So if I add 360 degrees to this, I'm going to get 315 degrees. That's a positive angle number, and it's going in a positive direction. That's a positive coterminal angle. So when I ask you to find one positive and one negative coterminal angle, that's what I mean. On the flip side, I could say negative 45, and I'm going to subtract 360 degrees from it. And I'm going to get negative 405 degrees. So it means I go a full circle, and then I end up right back here on the same terminal side. That is a negative coterminal angle, negative 405 degrees. Okay. Now for example B, to find a positive coterminal angle, I can do the exact same thing. I can add 360 degrees to this. 395 plus 360, 755 degrees. That's an example of a positive coterminal angle. All right, to find a negative coterminal angle, I would say 395 minus 360, I get 35 degrees. I'm going to draw that here. There's a 35 degree angle. One problem though, 35 degrees is still a positive number. It's still going in a positive direction. So this is actually still a positive coterminal angle. Even though I subtracted 360 degrees, because my number was larger than 360 initially, it's still a positive coterminal angle. That doesn't count yet. I need to subtract 360 again to get a negative coterminal angle. So I'm going to take 35 degrees and subtract 360 from that to give myself a negative coterminal angle. And I get negative 325 degrees. From my initial side, all the way around like that, that gets me negative 325 degrees. There's my negative coterminal angle. All right, so I have a positive coterminal angle and a negative coterminal angle, but I need to keep subtracting 360 to get to a negative number, or I need to keep adding 360 to get to a positive number. So for example B, I unintentionally found two positive coterminal angles. I found 35 degrees, I found 755 degrees. And I found one negative coterminal angle, negative 325. All right, now, problems 1 through 4, I want you guys to go ahead and practice drawing these angles in standard position, and then find one positive and one negative coterminal angle of each one of these. All right, let me know if you have any questions at all. So first thing you want to do with each of these 4 problems is go ahead and draw the initial side and the terminal side. So the first one, positive 65 degrees, that's going to end somewhere in quadrant 1. The second one was 230 degrees, positive. So that's going to end somewhere in quadrant 3. It's going to go 90, 180, 230. It'll end before we get to 270. third one, 300 degrees, that's going to rotate 90, 180, 270, 300, somewhere into quadrant 4. And the last one, 740 degrees, that's going to go full rotation 360. So I'm going to subtract 360 from that. And I get 380. So it's going to go another full rotation, another 360. And then it'll go 20 degrees past that. So that's somewhere in quadrant 1. So hopefully your drawings, your sketches look something like this, so that your drawings are ending up in the correct quadrants. That's the most important part for when we're drawing angles in standard position. Now to find positive coterminal angle, I can simply add 360 to some of these. So 65 plus 360, that gets me 425. That's a positive coterminal angle. Negative coterminal angle, I'll just say 65 minus 360. That's negative 295 degrees. That'd be an example of a negative coterminal angle for the first example. Problem 2, 230 plus 360, that gives me 590 degrees. There's a positive coterminal angle. So it would end at the exact same spot. And then I can say 230 minus 360, and I'm going to get negative 130 degrees. That's a negative coterminal angle. Problem 3, 300 plus 360 gets me 660 degrees. There's a positive coterminal angle. 300 minus 360 gets me a negative 60 degrees. There's a negative coterminal angle. Problem 4, I did 740 minus 360, so technically 380 is a coterminal angle. I subtracted 360 again. 20 is a positive coterminal angle, so I already found 2 positive coterminal angles. And then I can say 20 minus another 360, and I'm going to get a negative 340 degrees. And there's a negative coterminal angle. So I already found 2 positive coterminal angles when I was just trying to figure out which quadrant the angle itself was going to end in. And then I can go and find a negative coterminal angle because I just keep subtracting until I get to negative 340. Okay, so that's the idea for that particular problem. Okay, we're going to talk about radian measures today. This is the last thing we're looking at. And radians are very important in this unit. We're going to be using them a lot. So we need to make sure we practice them. It's basically another way of measuring, just like a degree is. So we know degrees are measured as a rotation in the circle. A radian is the exact same thing. It's just a different unit. It's like how we measure in feet, and then there's the metric system. So you can measure in feet or meters, but they're measuring the exact same thing. Radians and degrees are very similar. Radians are going to measure, 1 radian is basically whatever you find out the radius of a circle is, and you find that the arc of that circle is the exact same length, r over r, that would be 1 radian. So the terminal side is r units long, the terminal side of an angle, and then the arc is also r units long. That's what 1 radian is. Okay. Circumference of a circle is 2 pi r. So 2 pi times the radius, we might remember that as pi times d as well. But 2 pi r is the equation for circumference of a circle whenever you were trying to figure out basically what the perimeter of a circle is. And that means there are 2 pi radians in a full circle of radius r. Okay. And that means approximately 2 pi radians is about 360 degrees. So we can say that's the conversion factor. 360 degrees is the same as 2 pi radians. You could technically also say 1 pi radians is 180 degrees. Half of 360 is 180. Half of 2 pi is 1 pi. Okay. The way we convert between degrees and radians, when we're converting from degrees to radians, we're going to multiply degree measures by pi radians over 180 degrees. All right, that's how we do unit conversions. If you've taken chemistry yet, you might have done something called stoichiometry. That's also like a unit conversion type of thing. So it's the same idea here. We're just converting from degrees to radians. So that's our multiplier. Pi radians divided by 180 degrees. To multiply radian measures, we multiply by 180 degrees over pi radians. We just flip the fraction. 180 over pi instead of pi over 180. That's how we multiply one or the other. Let's go ahead and show you a couple examples here. First example, 125 degrees. We would start by just saying 125 degrees times pi over 180 degrees. And I can think about this as 125 over 1. That might make it easier to see that I'm just going to multiply directly across. And I'm going to get 125 times pi divided by 180. And that's 125 pi over 180 radians. That would be your number. But I can simplify that a little bit. So this is a radian measure. I'm going to say an unsimplified radian measure. But I've already completed the conversion. Now I just need to simplify. I see 125 and 180. I know both of those are divisible by 5. 125 divided by 5 is 25. 180 divided by 5 is 36. And then I need to look, can I simplify that anymore? Let's see. No, I can't pull 3 out of either of them. I can pull 3 out of the denominator, but not the numerator. Can only pull 5 out of the numerator. So that's it. This is simplified. So we always want to simplify our answers and leave it as simplified form. So leave as simplified fractions. So leave answers as simplified fractions. Okay. And example B, negative pi over 12, we would multiply by the opposite, 180 degrees over pi radians. And again, start by just multiplying straight across. Negative 180 pi over 12 pi. First things first, I see I can divide a pi out of both the numerators and denominators. So I get negative 180 divided by 12. Plug that into my calculator and that becomes negative 15 degrees. So that simplifies to negative 15 degrees. That's the idea for these last couple of problems. Converting from radian to degrees or converting from degrees to radians. All right, now I've got 4 problems I want you guys to practice. Remember, radian measures are going to be super, super important in this unit. I think we talked about them in AGS3 last year, but we are going to be using them a lot in Mod 6. So make sure you're comfortable with those. So go and try the last 4 now, and I'll put the answers up in just a minute here. So set them up The first two problems, we're going to do 135 times pi over 180. Second problem, negative 50 degrees times pi over 180. And then the second two problems, we would just flip that because they're already in radian measures. And we can tell when it's degrees because it'll have the little circle, and when it's radians because it won't have the circle. So we're going to multiply this by 180 over pi, and then pi over 10 times 180 over pi. So first thing I want to do is I want to say, let's go ahead and rewrite it as 135 pi over 180, and see if we can simplify that first problem. Well, I know I can pull a 5 out of each of those, and if I divide both by 5, I'm going to get 27 pi over 36. And then 27, I think I can simplify that. I think I can divide both by 9 still, and that's going to get me 3/4. So this becomes 3 pi over 4. Problem 2, rewrite as negative 50 pi over 180. And right off the bat, I can see I can divide a 10 out of both, get rid of some zeros. Then we're going to get negative 5 pi over 18. And that won't really simplify anymore, so that's it. Negative 5 pi over 18. For problem 3, I can multiply this together right now and say I get 180 times 5 pi over 4 pi. I can multiply 180 times 5 and I can get 900 pi over 4. But before I do that, I want to simplify because I know I can divide 180 by 4. 180 divided by 4 happens to be 45. You'll get the same answer both ways. It doesn't matter which way you do it. So now I have 45 times 5 pi over pi. Oh, and don't forget I can divide out a pi. So 45 times 5 is 225 degrees. So I get 225 degrees. If I did 900 divided by 4, I would also get 225. So it doesn't matter which way you do it when you're simplifying, but we end up getting 225 degrees. For the last one, number 4, I get 180 pi over 10 pi. Pi's will go away and I'm left with 180 over 10. 180 divided by 10 is 18. So I get 18 degrees for problem 4. That's it. That's the idea for today. So we have standard position angles, coterminal angles, and converting degrees to radians, converting radians to degrees, just being able to convert between those two methods. Your assignment tonight is pretty straightforward. I think you could probably finish it in the last 15 minutes that we have in class right now. Probably bust it out that quickly. All right, so you have 15 minutes left. Enjoy your Monday. Happy New Year, everybody, and we'll see you guys tomorrow. Thanks so much.